Okay, so I'm just going to go through the ones you sent me just to make sure everything's completely clear. This is question 4. It says, find the expected value of the above random variable. The expected value of a random variable is the sum of the products of each outcome times its probability. So I'm just going to take each outcome, which is 1, 3, 4, 5, and 9, and multiply them by their respective probabilities, and then just add them up. So this is going to be 0.2 times 1, 0.45 times 3, 0.25 times 4, and we're just going to add them up. So we have 0.2 times 1 plus 0.45 times 3 plus 0.25 times 4 plus 0.05 times 5 plus 0.05 times 9. And we get 3.25. Just want to double check that. Yep, that looks right. 3.25. Okay. The next one says a company prices its tornadoes insurance using the following assumptions. In any calendar year, there can be at most one tornado. So it's either yes or no. In any calendar year, the probability of tornado is 0.01. And the number of tornadoes in any calendar year is independent of the number of tornadoes in any other calendar year. That's basically just saying that these tornadoes follow a binomial distribution. So it says calculate the probability that there are fewer than 2. So that means 0 or 1. So I'm just going to use a binomial CDF. I want to know the probability of 0 or 1. So we have 11 trials. Chance of success is 0.01. I want to know the chance of 0 or 1 tornadoes. So I'm going to use an X value of 1. Let's do that again. Distribution binomial CDF. 11 trials. There we go. So that's where we get 0.99482. So that's their answer here. 0.99482. Okay. You might have done a chance of 3 or less. So remember, the CDF means that value or less. So if I want fewer than 2, I'm going to plug in 1 because I want to know the probability of 1 or 0. All right, this says when dragons on planet Pern lay eggs, their eggs are either green or yellow. The biologists have observed that over the years, 34% of the eggs are yellow, the rest are green. Next spring, the lead scientists have permission to randomly select 46 of the dragon eggs to incubate. Consider all the possible samples of 46 dragon eggs. What is the usual number of eggs in a sample of 46? So there's a formula from our notes that says this is just going to be mu plus or minus 2 sigma, which is the standard deviation. So sigma of a binomial is going to be the square root sigma of a binomial. This is from the formula sheet on our Blackboard page. Sigma of a binomial is the square root of n times p times q. So we're going to do the square root of 46 times 0.34 times 0.66. So it's 3.21. So we're going to do mu, which is going to be n times p. So we have 46 times 0.34. That's how many we expect if 34% are yellow. If there's 46 eggs, we expect 34% of them to be yellow. So we get 15.64. I'm going to do minus that. And then 15.64 plus. Oh, it's 2 times that. My mistake. So we're going to do this instead. So we'll take our sigma. And we're going to multiply it by 2. And then we're going to do 15.64 minus that. So we get 9.21 and 15.64 plus that. So we get a range of from 9.21 to 22.06. Now they round weird. So in these questions, they're going to round the bottom number up and the top number down. So this is going to be 22 and this is going to be 10. If it marks it wrong, I will fix it, but that's just how they want you to round it. I'm not actually sure why, but that's the way they want you to round it. Okay, this says the television show Letters has been successful for many years. The show recently had a share of 21, which means that among the TV sets in use, 21% were tuned to letters. I guess it's a knockoff of numbers. An advertiser wants to verify the 21% share value by conducting its own survey. And a pilot survey begins with 11 households that have TV sets in use at the time of letters broadcast. Find the probability that none of the households are turned to letters. So we want to know the probability of 0 households. Well, that's just a binomial PDF. One specific outcome. So we're going to say of 11 households, the chance that any of them is turned to letters is 21% or 0.21. I want to know the chance that 0 are turned to letters. So I get 0.074799 or 0.0748. At least one household? Well, if this is the chance of 0 households, this is just the complement. The second question is the complement. So I'm just going to subtract this from 1, and that's where I get 0.09252. And then it says find the probability that, well, you have that one correct. So just these two ones, I guess you have questions on. And I think that's it.